Hello everyone, this is Shalu Saxena and today's my topic is B-spline curve. So students, we have seen in Bezier curve there are the global points. Or we can say that these Bezier curves works on the global points, global control points. But in B-spline curve, we see that there are the local control points. So now let's see the difference between the global control points and the local control points. So in B-spline curve, we are going to see the B-spline curve. In B-spline curve, the degree of polynomial does not depend on control points. Does not depend on the control points. So let's see how. We are taking an example to see how this polynomial does not depend upon the control points. Let's see an example. Suppose we are seeing that in Bezier curve, there if we change the control points, let's suppose this is P1 and this is P2 and this is P3. Okay, so our curve is going like this. And suppose if we change the curve point P2 here, so our curve is totally changed. It is going to be like this. So these are the global control points. It depends on the global control points as we are changing. If we change the point, then the whole curve is totally changed. But to overcome this problem, we are going to see B-spline curve. So in B-spline curve, suppose we are taking the points P1, P2, P3, P4. Okay, so our curve is going to be like this. And let's suppose our point P2 is going to be changed. Suppose our P2 is like here. And if we are changing the position of the P2, then our curve is not going to be changed. Okay, so only this part of these curves are divided into knot vector, that is K1. The whole curve is divided into knot vector. Okay, so if we divide the whole curve into knot vectors, so we are taking that part of the knot vector curve change, and then whole curve is totally unchanged. So this is the difference between the Bezier curve and the B-spline curve. As we are taking the knot vector in the B-spline curve, so the position of the point which comes under the knot vector, only that part of the curve is changed, and the whole curve is is unchanged. Now we see that properties of the B-spline curve. So likewise we are seeing that in Bezier curve, we are taking the sum of the basic function. Here also the sum of the basic function at any parameter suppose u is equal to 1. So here is the sigma n plus 1 I is equal to 1 ni ku equals to 1. So already I told you that the whole curve is divided into k1, k2 and k3. Okay, so these are the order of k is the order of spline curve and where n plus 1 is the number of control points. So already I told you that this NIKU is equal to 1. It means that the whole curve is divided into the equal segment which is equal to 1. That is, the whole curve is divided in equal segments K1, K2, K3 and this is equal to 1. And now second property which states that the basic function is positive or 0 for all parameters values. It means that such that ni comma k is u is always greater than equal to 0. Okay, except for k is equal to 1. When the value of k is 1, then in spite of except k is equal to 1, if it is positive or 0, this nik value is greater than equal to 0. Now third point, we see that it allow the control points such that local control, as I already told you, here is a local control over the curved surface. Okay, now let's see fourth point. Fourth point says that curve lies within the convex hull. Within the convex hull. So as I already told you that B-spline curve is convex hull, means all the it lies under the control points. So here is the control point and the curve lies under the within the convex hull. Okay, if we change the change the point, then it doesn't change. It does only change that part of the point, and the whole curve is remain unchanged or same. Now fifth point says that the max degree of B-spline polynomial is independent on number of vertices of defining polygon. So its degree is independent on the number of vertices defining polygon. If we are taking the polygon, so its degree is totally independent on their number of vertices. So these are the properties of the B-spline curve. And in my next lecture I am going to tell you about the derivation of the B-spline curve. Thank you.